Okay, let's take a look at using the combination formula. So for letter A, we're going to express as factorials and simplify. Now we've got NC5 divided by n minus 1 C3. So what we're going to have to do is we are going to have to write this out. And then we are going to have to figure out what to do with it. I know I do not have enough space here for this, but let's try it out. So we've got, I'm going to write it out horizontally, NC5 divided by n minus 1 C3. Now I'm doing that because I know from this formula right here that we're going to end up with fractions divided by fractions. And that means we're going to be multiplying by the reciprocal. So, and sometimes I like to have this written out this way. So this becomes what? N factorial all over 5 factorial times n minus 5 factorial. All right, that looks pretty good. Divided by, on the top, we have n minus 1 factorial all over 3 factorial times n minus 1 minus 3 factorial. Okay. Now this looks like a monster. You're right. I need to go right to the end of the page. I'm going to go right down to the bottom of the page with this guy. So what this does, I'm going to rewrite n factorial. Well, no, let's not do that yet. N factorial divided by 5 factorial times n minus 5 factorial times 3 factorial n minus 4 factorial all over n minus 1 factorial. Okay. Now, let's see if we got stuff that's kind of close so we can cancel it. We got this n factorial and n minus 1 factorial. What does this mean? Well, before we do that, let's highlight a few other things. We got this n minus 4 and n minus 5 factorial. They're kind of close to each other. And then we got this 5 factorial and 3 factorial. We know we can cancel some stuff out from there. So we're going to cancel from those different colors. So let's take a look at n factorial. N factorial is n times n minus 1 factorial. Hey, that's neat. 5 factorial is 5 times 4 times 3 factorial. Right, because 3 factorial is 3 times 2 times 1. That's kind of nice. Now, then we've got n minus 5 factorial. I didn't change that one because I want to change the bigger one. See, in these pink ones, n minus 5 factorial is smaller than n minus 4 factorial. So we're going to multiply this with 3 factorial. Notice. Then n minus 4 factorial, that's n minus 4 times n minus 5 factorial. Do you see the pattern that we're getting here? Right, like imagine n is 10. Then this would be 6, then this would be 5, then it would be 4. And if n was 10, then this would be 5, and then 4, then 3. Right, because 10 minus 5 is 5 factorial. Now let's look on the bottom. we have n minus 1 factorial. Okay, now let's look at those colors again. Let's look at the orange. Oh, wrong thing. I want a highlighter. Well, let's undo first. Let's look at these orange guys. Let's look at the yellow guys. And then let's look at the pink guys. All right, so we've got some canceling that we can do. We can cancel out this n minus 1 and this n minus 1. We can cancel out this n minus 5 factorial, this n minus 5 factorial. We can cancel out this 3 factorial and this 3 factorial. And what we are left with is n times n minus 4 all over 5 times 4. There's our answer. Now, in case you haven't figured out, 6 factorial is equal to 6 times 5 factorial. N factorial is equal to n times n minus 1 factorial. Like this. N minus 100 factorial is equal to n minus 100. You take the first one and then you times it by one smaller than it. Now you can do it twice too, right? 6 factorial is equal to 6 times 5 times 4 factorial. So on and so forth. All right, so there's the first one. We're going to run out of space here again for the second one. Solve for n if 2 times n choose 2 is equal to n plus 1 choose 3. So we're going to write these guys out in their formulas. So we've got 2 times n factorial over 2 factorial and minus 2 factorial brackets is equal to, now it's got an n plus 1 over on this side, so it's n plus 1 factorial all over 3 factorial times n plus 1 minus 3 factorial. Okay. Now, let's simplify a couple of easy things first. This 2 and this 2. 2 factorial is just 2 times 1. It's just 2. So this guy's going to cancel out that guy. That's easy. This guy's going to simplify out. Right? It's going to become n minus 2 factorial. All right, so let's start with that. This becomes n factorial over n minus 2 factorial equals n plus 1 factorial all over 3 factorial times n minus 2 factorial. Ooh. Need O. Okay. Now, if we could get a common denominator, we can just look at the numerators, right? Well, look here. We've got 3 factorial here and n minus 2 factorial. So why don't we get this denominator to be 3 factorial? So we've got... so let's multiply 3 factorial times our denominator, but to keep it the same, we multiply by 3 factorial on the top. Now that our denominators are the same, we've got 3 factorial times n factorial is equal to n plus 1 factorial. We can just look at our numerators, right? We've got common denominators. So we can look at our numerators. Now, you might think there's some restrictions on our variables. Like, can n equal 2? Yes, it can, because 2 minus 2 is equal to 0, and 0 factorial is equal to 1. So in this case, n could be 2. But all we get in the end is we get 3 factorial times n factorial is equal to n plus 1 factorial. Yeah? Now we want to get all of our variables to one side and our answer and our numbers to one side. So we're multiplying here by n factorial. So let's divide both sides by n factorial. So we get 3 factorial. 3 factorial is 3 times 2 times 1. So we get 6 is equal to n plus 1 factorial over n factorial. Well, let's simplify this a little bit. N plus 1 factorial is n plus 1 times 1 less than that's n factorial all over n factorial. These cancel out, and we're left with 6 is equal to n plus 1, so 5 is equal to n. Whew. Now, we can check this by substituting n to our original equation, verifying it. So let's check it out. 2 times 5 choose 2. Does that equal 6 choose 3? Well, we got to see what those are. 2 times 5 choose 2, and 6 choose 3. Nope. I want to go to Desmos. Two times 5 choose 2. Right, we could write in front of it 2 times. Does that equal to 6 choose 3? Functions down at the bottom. 6 choose 3. Yes, it does. It works out. They both equal 20. Check mark. All right, so you need to know how to work with fractions, and you need to know how your factorials work in order to do these types of questions. All right, the last one, we'll look at combinations in Pascal's triangle.